Hey everybody, this is Mr. Longo, and in this video we are going to do our second part of partial fraction decomposition. And basically this is just a bigger, longer, more work type of example, okay? And the reason why is because your denominator has a factor that has a multiplicity greater than 1. And when that occurs, you need to put a denominator for each. So you need to come up with one for the single denominator and one for the squared or cubed or whatever. So you need one for each possibility. So that being said, let's get going. That means this example, we have a denominator of x plus 2. We have another denominator of our x minus 1 squared, which means you also need a denominator of just the x minus 1 for the singular term, which means this one's going to have an a, a b, and a c, which means this is going to end up being a 3x4 matrix when we get started. Okay, so everything else after this is pretty much the same. It's just got a little bit more work and a little bit more thinking involved. So for the first part, we need to do that thing where we get everything to have a common denominator. So your common denominator is our x plus 2 and our x minus 1 squared. So this a has a denominator of the x minus, or the x plus 2. We need the x minus 1 squared for this guy. B has the x minus 1 squared. It needs the x plus 2. And C only has one of the x minus 1s, so we need to give it an x minus 1 and the x plus 2. Okay? And now we're going to pretty much set up everything that we need to do from there. So we have our x plus, or x squared plus x is equal to, and this is going to be a times our x minus 1 squared plus b times our x plus 2. And then we have our c times x minus 1 and our x plus 2. Now this next step is just going to be to fix our parentheses for our x minus 1 squared and our x minus 1 times x plus 2. So what you want to do is FOIL x minus 1 with itself because we are squaring the whole thing. And that's going to give you x squared plus x is equal to a times, and that's going to give you x squared minus 2x plus 1, plus our b is good to go, plus c, and now we have to FOIL x minus 1 with x plus 2, and that's going to give us our x squared plus x minus 2. Okay, so for that step, all we really did was take care of all of our parentheses. Next thing we're going to do is distribute. So we're going to have x squared plus x is equal to ax squared minus 2ax plus a. Distribute your b, and you're going to have bx plus 2b. Plus, and then we're going to distribute our c. That's going to give us cx squared plus cx minus 2c. All right, so that part is now done. Now what we're going to do, and I might separate this step a little bit for you, the next part is working with the variables in terms of our x's, our constants, but now that we have more parts, we need to have one for the x squareds, and then we need to have another equation for the x's, and then another one for our constant or our numbers. Okay, so when you look through each of these, you need to come up with that. So our x squareds, if we look through this last line right here, we have x squared is our 1 x squared is equal to a x squared. There's no bx, but we have a c x squared. And if we're going to write this in terms of just our, leading coefficient for each one, this is going to end up being 1 is equal to a plus c for our matrix purposes. For our x's, if we go through and look for just our x's, we have a 1x is equal to a negative 2ax, and then we have a bx, and then we have a cx. And if we were to write that without any of our x's, that's going to give us 1 is equal to a negative 2a plus b plus c. And last, we have our constants. Well, this side doesn't have any, so we're going to use a 0 is equal to a. There's no b. I'm sorry, there's a 2b. And then we have a negative 2c. And again, all we're going to have to do with that is copy it over because we don't have any x's. So we have 0 is equal to a plus 2b minus 2c. And from this set right here, we are going to write our augmented matrix. Okay, so remember, that's the one where we're going to have our a, b, and c, and then we're going to have that vertical line, and then we're going to finish with our constants. So our augmented matrix is going to look like this. We have our a and c, so that is 1, 0, 1, and then our constant is 1. In the next row, we are going to have our negative 2 for the a, 1, and 1 for the b and c, and that's equal to 1 as well. The last one, we have a 1, 2, and a negative 2, and our constant is 0. And now, from there, we're just going to use our graphing calculator. We're going to type that into the graphing calculator, do our RREF, and we're going to end up with a is equal to 2/9, b is equal to 2/3, and c is equal to 7/9. So, to write our final answer for this problem, all we have to do is go back to what we had on top. A is 2/9 over, we had x plus 2. And then our b value is 2/3, so we have 2/3 over. And our denominator for this one was the x minus 1 squared, plus c, which is 7/9 over just your x minus 1. And that's it. You're done. So again, a lot of the work is up front, but of course the calculator is going to solve all of our system part for us to find our a, b, and c. But that's it for partial fraction decomposition part 2. This is Longo, and I'm out. See you, bye.